All right, so we are looking at how to apply double angle identities to actually, I don't know, doing something. The first one I assigned last night is page 14, number 14 on page 454, correct?
Yeah.
Does that sound right? And it said use a half angle identity to find the exact value of each function. We did this quickly at the end last night. It starts with cosine 15 degrees. 15 is half of what angle?
I did this one.
Excellent. Yeah, we did in class yesterday. 15 is half of what angle?
30.
30. Excellent. So what we're really looking at is the cosine of 30 over 2 degrees. Now, the half angle formula we had, if this were alpha over 2 from yesterday, this would be 1 minus cosine the full angle divided by 2, all under that square root. Is that the correct formula?
Yeah.
Cosine alpha over 2 equals 1 minus cosine alpha divided by 2, all under a square root?
Wait, is it sine is plus, cosine is minus?
Double check me. Is that correct? Should I have a plus there or minus there? How am I doing?
That's plus.
Cosine is plus.
Plus.
Thank you, Danny. Very good. I love that. So that's cosine plus. Okay, so now it's the correct formula. The plus or minus is in the formula, but but cosine 15 degrees, what quadrant is that in? On the unit circle. It's quadrant 1, right?
Yeah.
So cosine's positive. So when we'll only be dealing with positive, we can ignore the negative here. The cosine of 30 degrees is 1 plus. Cosine of 30 degrees is root 3 over 2, so I plug that in, right? And then I'm going to get 1 over 2 plus root 3 over 2 under my radical, which I'm going to make into I'm going to make that into 2 over 4 plus root 3 over 4, simplifying my fractions. So this answer becomes the square root of 2 plus root 3 all over 4. I can take the square root of top and bottom separately. So that's the square root of 2 plus root 3 all over 2. And I know it's positive because it's in quadrant 1. Now, using the half angle identity, what did I get for this yesterday? Using the not the half angle identity, excuse me, using the sum and difference identities, what do you get for cosine of 15 degrees? I did this on the board recently. Robbie, did you get that answer down? For cosine 15 degrees. Remember, we can also do this. We could also do this as cosine 45 degrees minus 30 degrees, right? And what formula would we use for that?
You just do
I know what it's called, but I don't know.
cosines of each.
Cosine 45, cosine 30, is this plus or minus? Plus. You switch it on the cosine one. Sine 45, sine 30. So that's our root 2 over 2, root 3 over 2, root 2 over 2, and 1/2. So that winds up being root 6 plus root 2 over 2. How can we get these two very different answers? This way, if we do the sum and difference formula, this one, we get this answer with the sum and difference formula, this answer with the half angle identity. Which one's right? Danny?
If you're multiplying root 2 over 2 times root 3 over 2, wouldn't it be
4?
root 6
What's
over
over
4?
4? Thank you.
And
Excellent. So my common denominator would be 4. Excellent. I'm making all sorts of silly mistakes up here. Okay, bigger point. These are two different answers. How can that be possible?
One of them squares 15 degrees.
No, they're both for 15 degrees. We just found them two different ways. If you use different methods in math, should you get different answers?
oh,
So what was-
if you solve that out with a calculator, it'll probably do the same thing.
The calculator, you're never sure it's exact with irrational numbers. Maybe if you go out 1,000 decimal places, it'll turn out to be wrong. That would give me a high degree of confidence, actually, though. I'd be 100% certain. Let's find out.
If you found out that it went 1,000 decimals back,
No, honestly, if I just looked at the calculator and these pretty much look the same, I'd be like, cool, they're the same. But we're not in a calculator mode today. Let's find out. I'm going to cross multiply. This is two fractions. I can do that. Have I cross multiplied correctly? All right, I'm going to divide both sides by 2, because that's just going to get in the way. Now what? I got a lot of radicals there. What do you do to get rid of radicals?
You square them.
I square them. Okay. I'm going to go ahead and erase this part. Stay on this board today. I'm going to square both sides of this equation. I'm going to square 2 times 2 plus root 3, all under that radical. And I'm going to square root 6 plus root 2. So this is just 6 plus 2, right? Square them both, add them, get 8. Is that right?
Mm-hmm.
Oh my God, stop nodding. No, it's not right. You have to FOIL. It is not correct. Don't fall for that. I'm making dumb mistakes up here. You guys should know you can't distribute the exponent if there's addition or subtraction. Can't distribute it across terms. You have to FOIL this one. This side's a little bit simpler. I can square the 2. What will that get me?
4.
And what is the square root of anything squared?
The
Whatever you
non-squared.
Whatever was under the radical.
Yeah.
Squared will cancel out the radical. So in this case, because this was all under a radical, it acted like parentheses. It let me treat these two terms as if they were a single factor, because a radical sign is a grouping symbol, just like parentheses. But please understand, I was not taking this squared and distributing across the plus sign. It was just canceling the radical, which had this entire expression in it. Over here is a different situation. Here, I actually have to FOIL. So, first, square root of 6 times square root of 6 will get me 6. My inner will be square root of 2 times square root of 6, which is square root of 12. My outer will be the same thing. My last will be root 2 times root 2, which is just root 2. I'm going to distribute on this side and get 8 plus the square root of 3. Over here, I'm going to get 8 plus... I'm sorry, that's not right. What mistake did I just make here?
You didn't put a 4 in front of root 3.
Did not fully distribute the 4. Very good. Over here, I'm going to get 8 plus 2 root 12. How close are these to being the same thing now?
Very, very good.
Closer.
Closer. Simplify the square root of 12 for me.
It's square root of 3 times 2 times 2.
It's
Well,
root
under
2,
there. It's still under the
root
square.
2 root 3.
Yeah.
Awesome. Yeah, I like the way Danny said it. Broke it down. It's the prime factorization is 3 times 2 times 2, all under the root.
Yeah.
And Rabia, what does that mean I can do with those two 2's?
Remove them.
Take it out and multiply it to 1/7.
Boom. So this side becomes 8 plus 4 root 3. So this answer we got from cosine 15 degrees with the half angle identity, and this answer we got with the sum and difference identity are exactly the same. They're both 8 plus 4 root 3 in simplest form. Or no, they're not actually both 8 plus 4 root 3, but if you square them both, you get 8 plus 4 root 3. Sorry, I'm not saying it well today. So we did prove that these two things were the same.
Wouldn't the denominators be different?
I took into account the denominators because my first step was to cross multiply. I multiplied 4 by this side and the 2 by this side. So that should take care of that. I'm being a little fast and loose with when you square things. You're getting rid of possible negative answers. But that actually won't be a problem here. So I'm cheating a little bit on this demonstration. But I do want you guys to think about you're answering the same questions you answered last week. Okay? You're just using a different formula, and the answers look different, but the cosine of 15 degrees is the same no matter how you find it. Does that make sense? That's my point for this one. All right. I'm going to erase this part now. That's the kind of thing I sometimes put on a test for extra credit. Take your answers and prove they really are equal. The way I just did and just erased.